Okay, let's unpack this. Welcome to the deep dive. Today we're embarking on, well, an extraordinary journey, really.
Absolutely, into some pretty deep territory.
Deep territory indeed. We're diving into the most profound questions humanity has ever grappled with, like our true place in this impossibly vast cosmos, the very nature of our unique existence, and
Right.
that peculiar, almost haunting fact that, well, we seem to be the only sentient beings out here asking these grand, ultimate questions.
It's that last one that always gets me. Why us? Or are we really the only ones?
Exactly. So today we're taking a stack of insights, from astronomers, physicists,
A
philosophers,
really rich mix of thinkers, people who've spent their lives pondering this stuff.
to try and understand what this whole cosmic perspective thing truly means.
Sorry.
And maybe more importantly, why it matters to you listening right now.
Yeah, what's the takeaway for everyday life? How does knowing this change anything?
Right. We're going to confront some of our, let's say, imagined self-importance
Uh-huh. Always a healthy exercise, I think.
and explore a side of existence that's, well, it's humbling, definitely humbling, but also surprisingly calming.
It is calming, isn't it? There's a strange comfort in the scale. What's truly fascinating here, I think, is watching how these different ideas,
Mhm.
ideas from totally different fields, they don't just sit there separately.
No, they connect. They really do seem to weave together.
They connect, they coalesce, they weave together, and what emerges is this profound sense of scale, yes, but also maybe purpose.
Purpose, even when we feel insignificant. That sounds contradictory.
Exactly. Even when faced with what seems like, overwhelming insignificance at first glance, it's a paradox we'll explore.
Interesting. Okay.
So our mission for this deep dive is really to pull out the key nuggets of knowledge from these sources, give you a shortcut basically to getting informed about our cosmic context without having to read, dozens of books.
Packed with surprising facts, hopefully some aha moments too, those moments where something just clicks.
Yeah, insights that aren't just facts, but things that might spark a real realization about your own journey, your own existence through all this.
I completely agree. And as we mentioned, our insights today come from a range of thinkers, but they all kind of orbit this central idea of the cosmic perspective. So let's kick off our journey onto this immense canvas of the universe. And let's start with an image that has quite literally reshaped how many of us view our home, our planet.
The immense canvas, understanding the cosmic perspective.
We're talking, of course, about Carl Sagan's iconic pale blue dot.
A truly legendary photograph.
If you haven't seen it, pause for a moment and just picture it. It's a photo taken by Voyager 1 back in 1990.
Way out there, 6 billion kilometers away.
Yeah, staggering distance, far beyond the main planets, almost at the edge of the solar system, and in that huge dark emptiness, there it is, just a tiny, almost invisible pixel.
A speck of light caught in the sunbeam, as Sagan put it so beautifully.
That's here, that's home,
Yeah.
that's us. It's an image that just instantly puts everything we think is so important, into this dizzying, humbling perspective.
Indeed. It's truly a profound realization when you stop and internalize what that single solitary pixel actually represents on that tiny dot. Think about it. Every single person you have ever loved,
Everyone you know.
every friend, everyone you've ever even heard of, every human being who ever was, lived out their entire lives right there.
It's mind-blowing when you phrase it like that.
Think about the sheer weight of all human experience crammed onto that point. All the joy, all the suffering.
Thousands of confident religions, all the big ideas.
The ideologies, the economic doctrines, everything we argue about, every hunter and forager, every hero and coward, every builder and destroyer of civilizations.
Teachers and peasants.
Young couples falling in love, mothers and fathers, hopeful children.
Inventors, explorers.
Teachers of morals, corrupt politicians, superstars, supreme leaders.
Saints and sinners.
Everyone. Throughout all of history, all of them live there.
On a mote of dust suspended in a sunbeam.
It's a truth that just hits you with the weight of cosmic scale. It's inescapable.
And it absolutely forces us, doesn't it, to confront what Sagan called our imagined self-importance.
And the delusion that we have some privileged position in the universe.
When you really look at that pale blue dot, I mean, really look and think about it, it challenges everything we think we know about our significance. Think about the rivers of blood spilled by all those generals and emperors throughout history.
All for the mastery of what? In cosmic terms, it's literally a fraction of a dot.
A tiny piece of a tiny piece. Or think about the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner.
Our constant conflicts.
Our frequent misunderstandings, our Our eagerness to kill one another, our fervent
The
hatreds,
posturing, the power struggle.
religious wars, all of it. It's rendered so starkly, shockingly insignificant when you see it from that distance.
It doesn't make the pain less real for those experiencing it, of course.
Yeah. No, not at all. But it reframes it, puts it in this vast, vast context.
And what's truly insightful here, I think, is how that image serves not just as a humbling observation, but as this powerful reminder of our shared vulnerability.
Yeah, we're all stuck on this little speck together.
Our planet is, in Sagan's words, a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, he points out there's no hint that help will come from elsewhere to save us from ourselves.
That's a sobering thought. We're on our own.
For the moment, yeah. Earth is the only world we know that has life. It's this incredibly precious oasis, and the Earth is where we make our stand.
It's not just poetry, is it? It feels like a profound call to action.
It absolutely is. It urges us to recognize our unique responsibility,
Sure.
precisely because we are so isolated and vulnerable.
Exactly. Astronomy, as Sagan suggested, really is a humbling and character-building experience.
You can't study the cosmos and maintain an oversized ego for long.
There's perhaps no better demonstration of the folly of human conceits than this distant image. For me, it deeply underscores our profound responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known.
The only one we have.
So if our home, with all its drama, all its history, is just a pixel, then how unimaginably vast, how truly immense must the stage be? Where does the speck even fit in?
And this is precisely where astronomy, the science itself, truly shines. While we all intellectually know the universe is vast, it's a concept we learn in school.
Yeah, space is big.
But astronomy gives us a true sense, like a true measure of that scale. It's one thing to say big, but it's an entirely different experience to truly try and grasp what that means in cosmic terms.
Okay, so let's try and grasp it. Let's take that cosmic tour, starting from our own familiar backyard, the solar system.
Right. Our sun feels enormous to us, dominates our sky.
Can't look right at it.
Exactly.
Yeah.
But it's just one star in the entire universe, one of hundreds of billions in our galaxy alone. It's incredibly easy to forget that.
And then we look out just a little bit further to our nearest stellar neighbors.
Alpha Centauri and Proxima Centauri,
Yeah.
the closest stars beyond our sun.
And they're about 4 light years from us.
Now let's unpack that light year concept, because it's fundamental to understanding cosmic scale.
Okay.
Light travels incredibly fast, 300,000 kilometers per second.
That's what? Around the Earth 7.5 times in 1 second.
Something like that, yeah.
Yeah.
Insanely fast. But space is so vast that even at that speed, light takes a full 4 years to get from Proxima Centauri to us.
4 years. Just for the closest star.
That's just the first tiny, tiny step out of our immediate neighborhood.
Wow. Okay, so where do we go next?
From there, our perspective just explodes outwards. We zoom out to our own galaxy, the Milky Way.
And this isn't just a few stars, is it?
Not even close. It's a vast collection of about 200 billion stars. Some estimates are even higher now, maybe 400 billion.
200 billion. That number is hard enough to imagine.
It really is. And to try and grasp the scale of the galaxy itself, consider this thought experiment. If we could, hypothetically, travel at speeds very close to the speed of light, which, physics says is impossible for anything with mass.
Right. Warp drive is still sci-fi for now.
For now, yeah. But even if we could, it would still take us more than 10,000 years just to come out of our galaxy.
10,000 years at near light speed. Just to get outside the Milky Way.
Just to get a clear view of it from the outside. That's how immensely spread out our home galaxy is.
And yet, it's just one galaxy.
Just one. One of billions, potentially trillions, in the observable universe.
Okay, so stepping outside our galaxy, what's next door?
The Milky Way isn't alone in this cosmic ocean. Our nearest large galactic neighbor is Andromeda.
Andromeda, I've seen pictures. It looks like a beautiful spiral, like ours.
It is. But to the unaided eye from Earth, it looks like just a tiny smudge in the night sky. A faint fuzzy patch, if you know where to look.
So it seems small from here.
Visually, yes. But don't let that fool you. Andromeda is actually significantly more massive and more luminous than our own Milky Way.
Really? Bigger than us.
Yeah, it probably contains maybe 1 trillion stars,
Mm-mm.
compared to our, say, 2 to 400 billion. It's the heavyweight in our local group of galaxies.
So why does it look like just a tiny smudge then?
Because of the sheer, almost unimaginable distance separating us.
Mm.
Andromeda is 2 million light years from us.
2 million light years. Okay, that 4 light years to the nearest star suddenly seems tiny.
Exactly. And this vast distance brings us to one of the most incredible, really mind-bending things that astronomy teaches us.
Which is?
Every time we look up into the night sky, we're taking a trip back in time.
The late travel time thing again. Okay, this really shifted my perspective when I first grasped it.
It's profound, isn't it?
Mm.
Think about it. 2 million light years to Andromeda. The photons, the tiny packets of light, entering your eye right now if you were looking at Andromeda.
Yeah.
They left Andromeda Galaxy 2 million years ago?
2 million years ago. So we're not seeing Andromeda as it is now.
No. You are seeing how Andromeda was 2 million years back in time. It's a genuine snapshot from the distant past.
A cosmic time capsule. Let's put that in human terms. 2 million years ago, what was happening on Earth?
Well, you were not even born. Your parents were not even born. That's obvious. But more profoundly, humankind had not even evolved on Earth. Homo sapiens did not exist on Earth.
Mm-hmm.
Our species wasn't around yet. Maybe some early hominins like Homo habilis or Homo erectus were walking the Earth.
Wow, so that light started its journey long before we even existed as a species.
Precisely. Yet that photon, after traveling for 2 million years across that vast, cold emptiness, it eventually found you. Passed through Earth's atmosphere, maybe through your telescope lens, through the tiny aperture of your pupil.
It hits my retina, triggers a signal.
And triggers a signal in your brain. What an incredible journey for a single particle of light.
That really highlights it. The further back into space we look, the further back in time we are looking. Every star is a history lesson.
Absolutely.
Yeah.
Each glint of starlight is a whisper from the past, some whispers older than others.
And our journey doesn't stop with Andromeda, does it? That's just our nearest big neighbor.
Not at all. Beyond our own Milky Way and Andromeda, our little local group of galaxies, there are countless millions of galaxies spread throughout the observable universe.
Millions or billions or
Billions, easily. Maybe even trillions now, based on recent estimates from deep surveys. And they vary wildly in size and brightness, in shape. Spirals like ours, giant ellipticals, strange irregular ones. It's a cosmic zoo out there.
So how do we even get a sense of that scale? It seems impossible.
It is incredibly difficult to visualize, but one of the most powerful tools we have for showing this is the famous Hubble Deep Field experiment.
Ah, yes, I've heard of this. What did they do exactly?
It was brilliant in its simplicity. Instead of pointing the Hubble Space Telescope at a bright star or a known nearby galaxy, they pointed it at a deliberately tiny region of the sky, a patch that looked completely empty to ground-based telescopes.
Oh, tiny.
Imagine holding a single grain of sand at arm's length, about that size area of the sky.
Okay, minuscule.
And then they just stared at it.
Yeah.
For a painstakingly long, 10-day-long exposure, collecting every single photon that arrived from that direction.
10 days staring at nothing. What did they find?
The results were absolutely breathtaking. Revolutionary, really. They defied all expectations. The Hubble Deep Field image showed that in that tiny, supposedly empty patch of sky, there were thousands of faint smudges of light.
Smudges.
And almost every single blob of light, no matter how faint or distant it appeared, in that entire picture is a galaxy in itself with billions of stars in it.
Wait, every blob. Thousands of galaxies in a patch the size of a grain of sand held at arm's length.
Exactly. Billions of stars in each one. This single image, perhaps more than any other astronomical observation, truly convinces us that we are living in a really, really vast universe.
It forces you to just stop and breathe and realize just how infinitesimally small our little corner is within this grand, sprawling cosmic tapestry. It's almost impossible to truly wrap your mind around.
It really is.
Mm.
But as awe-inspiring as this visible vastness is,
Mm-hmm.
the galaxies, the stars, we've still only scratched the surface of what the universe is truly made of.
Oh, there's more. It's not just stars and galaxies.
Far from it.
Mm-hmm.
And what we've discovered beyond the visible realm is, frankly, astonishing, even bordering on the completely enigmatic.
Okay, intriguing. What are we missing?
Well, get this. When a telescope like Hubble looks at a galaxy-filled field like the deep field, all those stars, all that glowing gas that's made of protons and neutrons, the stuff we call ordinary matter or baryonic matter.
Right, the stuff that makes up planets, chairs, us.
Exactly. But all of that visible stuff, it accounts for only about 10% of the ordinary matter that we think exists in the universe.
Only 10%. So where's the other 90% of the regular stuff?
That's what Hubble doesn't see directly.
Right.
And it tells an even more astonishing story. 90% of the ordinary matter, the protons, neutrons, electrons, is actually outside of these galaxies.
Outside, floating in the space between galaxies.
Yes, in a very, very diffuse state, is what astronomers call the intergalactic medium, or IGM,
And why can't we see it?
because it's so spread out
Yeah.
and mostly consists of ionized hydrogen and helium, which doesn't emit any light that we can detect easily across most wavelengths. It's incredibly tenuous, just a few atoms per cubic meter on average.
So how do we know it's there?
Primarily through indirect methods, like seeing how it absorbs light from distant quasars, and also through sophisticated computer simulations of the formation of galaxies and galaxy clusters.
Hmm.
These simulations show these incredible cosmic web structures, vast filaments and sheets connecting galaxy clusters. And that's where the models predict a lot of ordinary matter, atomic matter, is present. It's like the universe's invisible scaffolding.
Wow. Okay, so most of the normal matter isn't even in the bright, shiny galaxies we focus on.
Exactly. Stepping back, what this implies is that for most of cosmic history, when we've looked out at the universe and studied galaxies, we've literally been seeing only the tip of the iceberg, maybe 10% of the normal stuff.
That's already a huge shifting perspective.
It is. The majority of the material that makes up the ordinary universe is in this vast, almost invisible, diffuse state between the galaxies.
You said ordinary matter. Does that imply there's extraordinary matter?
Well, the mystery deepens even further when we consider the total cosmic composition. All that atomic matter, the stars, the planets, the gas inside galaxies, the gas between galaxies, everything made of protons and neutrons. It accounts for only a tiny percentage of the total energy density of the universe.
How tiny?
Only 4 to 5%.
Wait, 4 to 5%. That's all the normal stuff. Stars, planets, us, everything.
Everything you've ever seen, touched, or interacted with. Just 4 to 5% of the total stuff in the universe.
This is where the implications truly hit home, isn't it? The remaining 95%. What is it?
It's in a form that we have no idea of, fundamentally, which scientists collectively and somewhat placeholderishly refer to as dark matter and dark energy.
Dark matter and dark energy. We hear those terms a lot. What do we actually know about them?
Incredibly little. Beyond their gravitational effects and their profound influence on the universe's evolution and fate, we have these peripheral notions, as one source put it.
Okay, give me the notions. Dark matter.
Dark matter doesn't seem to interact with light at all, hence dark. But it clearly has gravity, lots of it. We infer its presence because galaxies and clusters of galaxies are spinning way too fast.
Right.
There isn't nearly enough visible matter to provide the gravity needed to hold them together. Without dark matter's extra gravitational pull, they should simply fly apart. So dark matter seems required for the formation of large-scale structures. It acts like gravitational glue.
Okay, so it's invisible stuff providing extra gravity. What kind of stuff?
That's the million-dollar question. Or maybe trillion-dollar question. We don't know. Leading theories suggest some kind of new elementary particle, something beyond the standard model of particle physics, but we haven't directly detected it yet, despite many experiments trying.
Right. And dark energy. That sounds even weirder.
It is, perhaps. Dark energy is even more mysterious. It's described as an elusive kind of energy that seems to permeate all of space. And unlike matter, both ordinary and dark, which clumps together due to gravity, dark energy seems to have the opposite effect. It creates a kind of negative pressure, pushing space-time itself apart.
Pushing it apart, so it's like anti-gravity.
In effect, yes. Observations of distant supernovae in the late 1990s showed that the expansion of the universe isn't slowing down, as everyone expected, due to gravity. Instead, it's expanding at ever faster rates. It's accelerating.
The universe's expansion is speeding up.
Yes. And dark energy is the name we give to whatever is causing this acceleration. Its nature is one of the biggest puzzles in physics today. Is it a property of space itself, a cosmological constant? Is it some new kind of energy field? We just don't know.
Mind-boggling. So if we put it all together,
You get this famous cosmic pie chart, roughly 68% dark energy, about 27% dark matter, and only 4 or 5% ordinary matter.
wow.
So this pie chart is actually telling us something profound. How little we know about the universe.
We only understand maybe 5% of what's actually out there.
Pretty much. For all our incredible discoveries, for all the amazing progress in cosmology, the vast, vast majority of reality remains a complete unknown. A profound mystery.
Here's where it gets really interesting, though. What does this mean for the future?
It means we are far from writing the final chapters of our exploration of the universe. There are huge discoveries still waiting to be made.
The future definitely looks like a fertile field of discovery then, full of unanswered questions.
Absolutely. It's an exciting time to be studying the cosmos, precisely because we know how much we don't know.
And what's truly compelling for me is how this sense of scale, this vastness of the unknown, isn't just out there. It also shows up right here, inside us,
Right.
in our own biology.
Ah, you're thinking of Neil deGrasse Tyson's analogy, the biological cosmic perspective.
Exactly. It's such a brilliant and kind of humorous way to bring this home.
Yeah, he asks us to consider the microbes living in our own bodies, specifically the ones in our lower colon.
Right. He points out with that characteristic twinkle he has.
That in just 1 centimeter of your lower colon lives and works more microbes than the total number of humans who have ever been born.
That number always stops me. More microbes in 1 centimeter of me than all humans ever.
It's a staggering comparison, isn't it? Billions upon billions of bacteria, archaea, fungi, a whole ecosystem within you.
Okay, let's unpack this for a moment then. You might think you're the boss, right? The master of your own body, the big brain running the show.
Uh-huh. Our default perspective.
But to these countless microbes, your entire existence is basically just a dark anaerobic vessel of fecal matter.
Uh-huh. It's a hilarious and deeply humbling thought, isn't it? Puts you in your place.
You think you're in command, but if you eat something bad, something that upsets their delicate balance, they very quickly demonstrate who's really in charge.
They'll send you straight to the bathroom. No question about who has the power then.
It perfectly highlights this deep, undeniable codependence.
Exactly. You exist and thrive because they're busy doing your digesting, breaking down food, synthesizing essential vitamins like K and some B vitamins.
Things we can't do for ourselves.
Right. And they exist and flourish because you provide this warm, stable, nutrient-rich environment for them to live in.
It forces you to rethink being entirely separate, even within your own skin. We're walking ecosystems.
We really are. And this biological cosmic perspective extends even further, connecting us back to the stars in the most fundamental way.
Ah, the Stardust connection.
Yes. The idea that the atoms in your body are traceable to stars that have exploded across the galaxy.
Supernovae.
Exactly. These ancient stellar explosions forged heavier elements beyond hydrogen and helium. The carbon, nitrogen, oxygen, iron. All the elements essential for life as we know it. They spread that enrichment into gas clouds that would later make star systems
Like ours.
that have enough elements like carbon, nitrogen, and oxygen elements of life in order to make planets and life upon it.
So the iron in my blood, the calcium in my bones, the carbon that forms the backbone of my DNA.
Forged in the heart of a dying star billions of years ago. Ejected into space, traveled across the galaxy, became part of the nebula that formed our sun and Earth, got incorporated into the planet, into the food chain, and now it's part of you.
For me, this is the deepest cosmic perspective there is, the one that truly resonates.
It's powerful.
It's recognizing that not only are we, with our thoughts and questions, living in this universe, but in a very real physical sense, the universe is living within us.
We are literally made of stardust.
Every breath, every thought, every cell, woven from the ashes of ancient suns. It's this profound, beautiful, undeniable connection tying us directly to the grand cosmic drama.
It really is.
So, if the universe is within us, and we are this small, yet somehow remarkable part of this vast, mostly unknown cosmos, what does that mean for our own existence? What is this experience of being alive?
The enigma of human existence.
And that profound line of questioning leads us straight into the territory of philosophy, doesn't it? To that fundamental theosophical itch that thinkers like Alan Watts talked about so well.
Right. He often said that just the fact of existence itself, existence as such, was weird.
Yeah. He just posed the question, maybe with a little smile. Here we are. Isn't that odd?
It sounds so simple, but it's loaded, isn't it? What did he mean by odd?
Well, he was playing with the word odd stands out from even. You need the flat, even background to even notice the odd thing sticking out. So space, the void, maybe that's the even. And each one of us, each unique thing, we're odd, strange, unique, particular, different. We stand out against the backdrop.
And that feeling that we are distinct, that we exist,
Yeah.
that creates this philosophical itch, this curiosity.
Exactly. Makes you scratch your head and ask, why? Why is that so?
But Watts pointed out that why is maybe the wrong question here.
He suggested it's ultimately a bit meaningless in this context. Asking why existence happens implies some external purpose giver, which is an assumption. So you shift your inquiry. You move from why is it so to how is it so?
And that shift from why to how, that leads us towards science.
Directly. How? Questions are what science tries to answer. How does gravity work? How did life evolve? How does consciousness arise from neurons? That's the realm of scientific exploration.
Okay, but then there's that other question Watts mentioned,
Yeah.
the really big one. what is it? What is existence itself?
Ah, yes, the fundamentally unanswerable one, perhaps, or maybe meaningless in its ultimate sense.
Why unanswerable?
Watts explained it beautifully. If you could answer, what is existence? What terms would you even use for the answer? We classify everything we encounter, right? Animal, vegetable, mineral, Republican, Democrat, male, female, solid, liquid, gas.
We put things in boxes to understand them.
Exactly. But to answer what is it for existence itself, you'd need a box that contains all the boxes, a class of all classes. But we can't imagine what the outside of that ultimate box would be. There's no external reference point from which to define the totality of everything.
So the question sort of collapses on itself. You can't step outside existence to define it.
Precisely. It remains elusive by its very nature.
And this elusiveness of what it is, this ties into how science itself shifted its view of reality, away from stuff.
Yes, absolutely. He argued that physicists, especially in the 20th century with relativity and quantum mechanics, finally abandoned the quest for stuff.
They gave up looking for the ultimate tiny building blocks.
In a way, they started describing the universe entirely in terms of form, the pattern, not the stuff.
Give me an example.
Think about looking at a piece of carpet. Looks like solid stuff, right?
Fibers.
Okay, put it under a microscope. The apparent stuff start to disappear. You see a crystalline structure, an arrangement.
Okay.
Turn up the magnification way higher. Those crystals become arrangements of molecules, still pattern.
Right.
Turn it up again, down to the quantum level. Molecules become atoms, then electrons and nuclei, then quarks and leptons. And what are they? They behave like waveables, patterns of energy, probabilities, vibrations, and quantum fields.
So the solid substance or stuff we started with.
It totally vanishes. It's replaced by dynamic patterns, relationships, mathematical forms. Reality at its most fundamental seems less like tiny hard marbles and more like a dance or a song.
Wow. Okay, so it's not what it is, but how it behaves, how it's structured.
That's a shift in perspective. It's all about the form, the pattern, the process.
So this raises an important question then. If existence is fundamentally pure pattern, pure form, rather than solid stuff.
Wow. How does that shift our understanding of what's real or substantial? That's the million-dollar philosophical question, isn't it? It suggests that reality isn't static. It's not a collection of things, but maybe a dynamic, flowing, ever-changing process, a cosmic symphony playing itself out.
And if reality is a process, like music, does that change how we think about meaning?
It certainly invites us to. Maybe meaning isn't found in static objects or final destinations, but in the unfolding process itself, in the music.
Which brings us right back to that other fundamental question many of us grapple with all the time. Does it matter?
And we mean that in two senses, don't we? Does it have substance, and is it important?
Right. Is my life, is human existence important? Does it measure up to anything in this huge, ancient, patterned cosmos?
Watts had a fascinating take on this, connecting the English word matter back to its roots.
Okay.
He linked it to the ancient Sanskrit root matra, which means to measure.
To measure, okay.
And from that same root, matra, you also get the word maya.
Maya, often translated as illusion.
Often, yes, especially in the West. But in Hindu and Buddhist philosophy, Maya also carries these deeper connotations of magic, art, creative power, the divine play or illusion that is the manifested universe. It's not just fake, it's the performance, the artistry of reality.
So matter, measure, Maya, magic, illusion, creative power, they're all connected.
Etymologically, yes.
No.
So Watts, in his wonderfully playful way, suggests that maybe instead of agonizing over whether we objectively matter, we should just say, let's pretend that we matter.
Just decide to act as if it's important.
Kind of. Engage with life fully, playfully, creatively, without needing some external cosmic stamp of approval saying, yes, you are important. Participate in the Maya, the dance.
He then expands on this, using that beautiful analogy of the world as a musical phenomenon.
Yes. This is one of my favorite Watts metaphors. He says, think about good music. Does it refer to something outside itself?
Not usually. Instrumental music, anyway.
Right. You don't ask a great composer or musician, what do you mean by this symphony? What's the message?
No, the music is the meaning.
Exactly. The meaning is simply, listen, that's the meaning. It is self-referential, self-sufficient. Its value is intrinsic to the experience of listening.
And he applies this to everything.
To everything. He says giraffes are giraffing, trees are treeing, stars are starring, clouds are clouding, rain is raining.
And people are peopling.
Exactly. The meaning isn't some external goal we need to find or achieve. It's found in the very act of existing and doing what we do, in the process itself. You are the meaning, just by peopling.
So what does this all mean then for us trying to live meaningful lives?
Perhaps. Perhaps the deepest meaning isn't something we find outside ourselves, or something we're given by some authority.
That's something we are.
Something we are in the very act of living, in our unique, complex, sometimes messy, but always unrepeatable peopling. It's in the intricate dance of our own existence. The meaning is the dance itself.
That's a beautiful and kind of liberating thought.
It is, yet, despite this inherent peopling, this beautiful intrinsic dance of life, we often struggle deeply with the fact that our individual performance has an end.
Yeah. The conclusion of our personal symphony. Death.
Which it inevitably brings us to the very human desire to avoid it, right? The wish to cheat death.
We hear about some pretty wild, futuristic ideas, like removing their brain and putting it into a different body.
Uploading consciousness.
Or putting it into a robot body.
Right.
Mind uploading, brain transplants, all that sci-fi stuff.
Right. But as Neil deGrasse Tyson points out, while those ideas capture the imagination, they face enormous, maybe insurmountable technical and philosophical hurdles. What is consciousness? Can it be transferred?
So what does he think is more realistic in terms of extending life?
He mentions the experiments they're doing, say, with mice, manipulating their biology to prolong their lives. And they do live longer, sometimes significantly.
But not forever.
No, even with interventions, animals don't live forever. There seems to be some fundamental limit, maybe related to entropy or accumulated damage. He suggests that manipulating our genome, actually altering our fundamental genetic code to slow aging or repair damage, is probably much closer to a viable path for significantly prolonging human life than these more drastic brain transfer scenarios.
Okay, so maybe we can live longer through genetics.
Yeah.
But what if we could achieve true immortality? What would that even look like?
Well, setting aside the how, there are immediate and pretty massive societal implications we'd have to face.
Like what?
If everyone, or even just a significant portion of people, lived forever or even for centuries, the world's population would skyrocket. We'd rapidly outstrip the resources to support it.
Food, water, energy, space.
Exactly. Imagine the strain. Billions of people living indefinitely. This scenario would absolutely necessitate finding another orb to accommodate our overproduction of air-breathing humans.
We'd need to become a multiplanetary species, fast.
And not just land on Mars, but deploy truly revolutionary terraforming technologies to make other planets genuinely habitable on a massive scale.
Which we have no idea how to do yet.
Not even close. And we'd also need unbelievably advanced transportation to get huge numbers of people there, warp drives or wormhole transportation systems.
So immortality quickly becomes an overwhelming logistical, resource, and maybe even ethical nightmare. Who gets to be immortal?
Precisely. It raises more problems than it solves, perhaps.
So why do we crave it so desperately then? Why this deep-seated desire to live forever?
Tyson puts it very simply. We want to live forever because we fear death.
And why do we fear death so much?
Because we are born knowing only life. From the moment we become conscious, all we experience is existence, being here. Death is the ultimate unknown, the cessation of everything familiar.
But he makes a fascinating point about the flip side.
Yes. What's truly interesting is that we don't fear having never been born.
Right. Before I was conceived, I wasn't aware of not existing.
Exactly. Were you conscious before you were conceived? Did you complain, where am I? How come I'm not on Earth?
No, there was no me to complain.
No, you simply didn't exist. There was no subjective experience of non-existence.
Okay. So how does that relate to death?
Well, while religion often offers detailed accounts for what happens after death, providing comfort, stories, frameworks like Valhalla, heaven, hell, reincarnation,
Science takes a different approach.
science, being based on empirical evidence, doesn't have much to say about Valhalla or Elysium or Hades or heaven or hell or the spirits of your ancestors. It can't test those claims.
So what does science say about death, the physical reality?
The cold, hard, observable facts tell us that upon death, there is no evidence that you experience the consciousness you enjoyed while alive.
Because the brain stops working.
Yes.
Yeah.
The brain, which is the electrochemical source of all your thoughts, feelings, and sensory awareness, becomes starved of oxygen. Its intricate neural networks cease firing. The patterns that constitute you dissolve.
We know this is effectively you disappearing.
We see tragic glimpses of this process in conditions like severe dementia or people who experience a series of ultimately fatal strokes. They tragically and systematically lose function of their mind and body as they descend into a state of non-existence, even before biological death. It's a fading out of the self.
It's a stark reality.
Yeah.
But framing it through that pre-birth perspective helps.
Tyson argues it does. He suggests your non-existence before life bookends your non-existence after death.
The state before and the state after are symmetrical. A state of no consciousness, no experience.
From a scientific viewpoint, yes. Death is simply a return to that state of non-existence you were in before you were conceived. The universe continues, the patterns rearrange, but the specific conscious entity that was you ceases to be.
So if we connect this to the bigger picture, maybe the fear of death, while totally understandable and deeply human.
It isn't necessarily a cosmic imperative. It's not written into the laws of physics that we should fear it.
Right. It's a fear rooted in our particular biological setup, our attachment to this conscious experience we call life.
Exactly. It's a product of knowing only life. And paradoxically, maybe accepting our finite nature, accepting that our performance does end.
That can actually lead to a deeper appreciation for the performance itself, for the life we do have.
Precisely. It brings us to the profound preciousness of this brief, magnificent existence we've somehow been granted.
Which brings us to just how precious it is, statistically speaking, this idea of existence against stupendous odds.
Yes. Let's really consider the typical human journey for a moment. It starts with conception, often the single most intimate act of human affection.
Then 9 months of development.
Gestation in utero for 9 months, this incredibly complex biological process, followed by total dependence after birth, needing to suckle for another 12 months or be fed.
And then continual care through our toddler years as we learn the absolute basics, walking, talking, understanding the world.
It's an immense investment of time, energy, and care just to get a human being started.
And then comes years of schooling, learning complex skills, forming deep friendships, participating in seasonal rituals and cultural practices that bring us together and shape our societies. It's this incredibly intricate, tender, resource-intensive developmental path.
And yet, despite all this intricate development, all this capacity for connection and nurturing, humanity presents this profound paradox, this baffling contradiction.
The darker side.
While we're capable of such incredible creation and cooperation, we also possess this chilling capacity for destruction. We invent, refine, and perfect anti-personnel weapons such as landmines, assault rifles, missiles, and bombs.
Weapons designed solely to end human life, often horrifically.
Any one of which can extinguish that entire intricate developmental journey in an instant. Wars have taken a staggering toll, millions upon millions dead, and even outside of declared wars, humans murder other humans at a truly horrifying rate. Tyson quotes a figure exceeding 400,000 homicides per year worldwide.
400,000 lives, each one representing that incredible journey cut short every year.
It really forces you to stop and ask that question again. Do you really know how precious life is? Do we as a species truly internalize the value of what we so readily destroy?
That question hits even harder when you look at the sheer odds against any one of us being here in the first place.
Right. The statistics are just mind-boggling. Think about the total number of people who have ever been born on Earth. What's the estimate?
About 100 billion is the figure Tyson uses, which sounds like a huge number, right? 100 billion people across all of history.
It does. But then compare that to the potential diversity of human beings allowed by our genetic code.
Okay.
Our DNA, that incredibly complex blueprint for life, is capable of generating. Well, the number is almost comical in its size. At least 10 to the 30th variations of viable humans.
10 to the 30th, that's a 1 followed by 30 zeros.
Yes. 1,000,000,000,000,000,000 possible unique genetic combinations. This astronomically huge number compared to the mere 100 billion who have actually lived.
It means that most people who could ever exist will never even be conceived. The overwhelming majority of potential human lives will never happen.
You, me, everyone listening. We're the lucky few who won the cosmic lottery against literally astronomical odds.
Just by being born.
This profound statistical reality compels the conclusion that each of us, for all practical purposes, is unique in the universe now and forever. The chances of your exact genetic makeup, your exact experiences ever repeating are effectively zero.
So given this unbelievable privilege, this statistical miracle of existence.
Being alive is the time to celebrate being alive every waking moment. It's an imperative derived from the sheer unlikelihood of it all.
We should strive to make the world a better place today than yesterday, simply for the privilege of having lived in it.
It's a call to embrace our unique existence, understand its preciousness, and try to make it count for something positive.
And thinking about the end, about legacy, Neil deGrasse Tyson reflects on what he'd miss most if he were on his deathbed. It's not personal possessions.
No, he says he'd be sad to miss the future clever inventions and discoveries that our collective human ingenuity will undoubtedly produce, the things we haven't even imagined yet.
And he'd wonder about the trajectory of society, whether civilization's arc of social progress will continue. Will we keep getting better?
It's a hope, isn't it? A deep yearning that our primal urge to keep looking up, our curiosity, our wonder about the cosmos.
It's hopefully surely greater than our primal urge to keep killing one another.
If that hope holds true, then human curiosity and wonder, the twin chariots of cosmic discovery, will ensure that starry messages continue to arrive, that we keep learning, keep expanding our understanding.
And these profound insights from looking up, they should ideally compel us for our short time on Earth to become better shepherds of our own civilization.
It reminds me of that powerful epitaph of the 19th century American educator Horace Mann. A truly inspiring challenge.
What was it?
Be ashamed to die until you have won some victory for humanity.
Wow, that sets a high bar. Win some victory for humanity.
It does. It frames life not just as existence, but as opportunity. An opportunity to contribute something meaningful, however small, to the collective human story.
So, summing up this section on existence, if we weigh it all.
Yes. Life is better than death, most would agree, and maybe life is also better than having never been born, given the richness of experience it allows.
But the real revelation, the core insight from this perspective, is that each of us is alive against stupendous odds.
We get this brief, improbable window to experience the universe. We get to invoke our faculties of reason to try and understand it.
We get to smell the flowers, simple pleasures.
We get to bask in divine sunsets and sunrises, witness the beauty of our own planet.
And we get to gaze deeply into the night skies they cradle, connecting with that vastness we came from.
We are given this incredible, unlikely opportunity. We get to live and ultimately die in this glorious universe.
The unique quest, are we alone in our questions?
Okay, so we've journeyed through the sheer scale, the vastness, the unknown nature of the cosmos. We've touched on the almost unbelievable preciousness and uniqueness of our own fleeting existence, born from stardust against incredible odds.
And found the universe reflected right back inside us.
Exactly. Which brings us, I think, to the capstone question. The one that perhaps underpins all of astronomy, maybe even all of human intellectual curiosity.
The big one.
Astronomy, at its heart, isn't just about mapping stars or measuring distances, is it? It's fundamentally a scientific journey guided by physics.
But concerning itself with some of the most profound questions that the human mind has ever bothered to ask.
These are the ultimate questions, the ones that keep philosophers and scientists awake at night.
Absolutely. The truly fundamental inquiries that have driven human thought for millennia. Questions that really get to the core of reality.
Why?
Well, the very first one. Did our universe have a beginning? Was there a Big Bang or something else?
And if it had a beginning, the inevitable follow-up. Will our universe ever end? Will it expand forever, collapse back, rip apart? What's the ultimate fate?
Then there are the how questions about its properties. How old is the universe? We have a pretty good number now, about 13.8 billion years, but refining it continues.
And as we've discussed at length, how vast is the universe? How big is the universe? Trying to map its full extent.
The origin of substance itself. All the things that we see around us, all the matter, including ourselves. What is the source of this matter? Where did we come from? The origin of elements, the origin of life.
And that incredibly slippery concept we just take for granted. What is the nature of time? Can we even come up with a physical description of what time is beyond just measuring its passage?
These are the grand challenges. These are the questions that drive us to build bigger telescopes, more powerful particle accelerators, more sophisticated experiments.
But here's the next layer, the twist that makes it even more profound for us. The central question for this deep dive, the one that really ties the cosmic perspective to the human condition, is perhaps the most humbling and inspiring of all. Are we the only sentient beings in this entire universe asking these super ultimate questions?
Yeah. Are we alone in this universe in our quest for understanding? Is anyone else out there looking up and wondering,
We know we are not the first generation to ask these questions. This isn't new.
Not at all. Ever since humankind first looked up at the night sky, from ancient Babylonians tracking planets to Polynesian navigators using stars to modern scientists.
We have been scratching our heads trying to find a purpose for our own existence, trying to make sense of it all.
And we have been trying to tell the story of the universe, to construct narratives that explain where we came from and where we fit in.
So here's where it gets really interesting. This whole endeavor, this cosmic quest. It isn't just about understanding the stars and galaxies out there.
No, it's fundamentally about understanding us, our unique place, our unique capacity for this kind of profound inquiry. Why are we the ones asking?
Which is a huge question. But it's also crucial, isn't it, to acknowledge that the scientific story isn't the only story.
Absolutely vital. Astronomy and the scientific method provide an incredibly powerful, evidence-based framework. They offer one version of what the universe is and the story of the universe.
But it's not the only way humans make sense of things.
No. And it's important to recognize that science is not the only way, nor necessarily the only legitimate way, to engage with the world around us.
This raises an important question then. How do we integrate these different forms of knowledge? How do we build a truly holistic understanding of our reality using all the tools we have?
That's a challenge for all of us, isn't it? How to hold multiple perspectives at once.
Because we have so many other uniquely human ways of exploring and expressing our experience. Each offers a different but potentially valuable lens.
Like what?
Well, there's art, we have music, there's literature, there's poetry, ways of exploring emotion, beauty, subjective experience.
Then there's politics, there's economics, systems for organizing our societies.
And there's spirituality, philosophy, ways of seeking meaning, ethics, and understanding beyond the purely physical.
Each one of these endeavors, you could argue, is legitimate. Each one of them is important.
Because they try to provide us with a slightly different way of looking at the world around us and our own place in it. They address different human needs, different kinds of questions.
Science might tell us how the sun shines, but poetry might capture how the sunset feels. Both are valid parts of the human experience.
Exactly. But while acknowledging the value of all these approaches, the sources we're drawing on today really emphasize that one can learn a great deal from science if we pay attention.
We shouldn't dismiss the power of the scientific worldview. It offers something unique.
Right. It can be as enriching, as entertaining, and as liberating as great art, great music, or spirituality. It has its own kind of beauty, its own kind of awe.
The beauty of understanding the underlying patterns, the elegance of physical laws, the sheer mind-boggling scale revealed by observation. That's a unique kind of enrichment.
And this brings us full circle back to the power of cultivating this cosmic perspective in our own lives.
Why it's worth doing.
It's very important that once in a while, occasionally, even if we're busy with everyday life, we tune into science and try to understand what's happening in the world of science.
Just check in with the latest picture from Hubble or read about a new discovery.
Because engaging with this scientific worldview can change the way we understand ourselves and our place in the universe. It can genuinely shift your perspective.
It's about revisiting that core idea from Sagan, that truth and science provide a very humbling and character-building experience.
It chips away at our tendency towards self-centeredness.
And practically speaking, as you go through your daily life, getting pushed and pulled by the vagaries of life,
Dealing with work stress, family issues, successes, failures.
counting your losses and gains, getting caught up in moments of intense ecstasy or deep agony.
Science, or rather the cosmic perspective it offers, provides a kind of anchor, a grounding.
It tells you to stand and stare at the cosmos once in a while. Just take a moment. Look up.
It suggests it's important you keep staring at pictures like the pale blue dot in the Hubble Deep Field.
Let those images sink in. Use them to put your problems, your triumphs, in the right perspective.
The cosmic perspective, not to diminish the reality of your feeling.
No, but to contextualize them within the sheer scale of space and time. It can shrink problems down to a more manageable size sometimes.
Conan O'Brien shared a sentiment once that just perfectly captures this feeling for me. It really resonated.
Oh, yeah. What did he say?
He talked about how he finds himself strangely calmed by the notion that things are much bigger than I am. He said when he sees a big mountain or some massive structure out in the desert, something ancient and enduring, he finds it's a reality check.
Yeah.
He thinks, that was there a million years before me. It's going to be there a million years after me. It doesn't care. And his conclusion was, I don't count. In a good way.
In a good way. That's the key, isn't it?
Ah.
It's not about feeling insignificant in a negative, nihilistic sense.
No, it's a liberation. It's freedom from the crushing weight of feeling like everything revolves around you, that your problems are the biggest things in the universe.
It allows you to just breathe, to be part of something much, much larger.
It truly is a liberating thought, and it underscores that ultimate profound connection we talked about earlier.
That maybe we are special because we're the same.
How do you mean?
Special in our shared origin, our shared substance.
Right.
We are one not only with each other, but with the universe itself.
Because we're made of stardust.
Because we're made of stardust. When we truly internalize that not only are we living in this universe, the universe is living within us, that the cosmos is expressed through us.
That's the deepest cosmic perspective of all. It transforms feeling small into feeling connected, feeling part of something immense and ancient.
It shifts insignificance into belonging.
So what does this all mean? For you, for us, right now, listening to this?
The sheer beauty of it, I think, is that the universe isn't just some distant, abstract concept out there.
It's right here.
It's intimately within us, in every atom, every breath, constantly reminding us, if we choose to listen, of our profound connection to everything that is, everything that has been, and everything that ever will be. Outro. So we've taken quite a journey together today. We went from the breathtaking, almost incomprehensible vastness and the deep mysteries of the cosmos.
Thinking about dark matter, dark energy, the sheer scale of it all.
Right. Then we zoomed right in to the precious, unique, and undeniably fleeting nature of our own human existence.
Born against stupendous odds, made of stardust.
Exactly. And finally, we arrived at our distinctive, perhaps even unique, capacity as a species to ask the ultimate questions about reality itself, to wonder about our place in it all.
This wasn't just, a random collection of facts or a simple summary of interesting ideas.
No, we aimed for this to be a curated experience, something designed to hopefully shift your perspective, even just a little, to offer some genuinely profound insights into your place, your unique place, in this grand cosmic story.
And as we close this deep dive, let's leave you with one final, powerful thought to mull over. Something building on everything we've explored today.
Consider this. Each one of us listening right now, you are a singular, unrepeatable expression of the cosmos, born from the heart of exploding stars forged from their ashes.
You are alive, you are conscious, you are pondering your own existence, all against truly stupendous, almost impossible odds.
And as far as we currently know, we humans are the only sentient beings in this entire colossal universe asking about the very fabric of reality, about its beginning, its end, its meaning, its purpose.
Given that astonishing, almost incomprehensible privilege, this precious fleeting moment you have in this glorious, mysterious universe.
What incredible, unique victory for humanity. However you define victory, however big or small will you strive to achieve.